Hello and welcome back for another VMK in the game development series. In this VMK, I'll be showing you the inner workings of the GUIList control. Now, the good thing for you guys is that you won't have to type anything in this tutorial, because I'm going to actually provide you all the source code that I've written. There's a fair bit of complex sort of calculations involved, and I didn't want you guys to mistype something or change a sign here or there. I want you guys to have a working GUI list. So I'm giving you the code that I wrote, which I've tested and I know that works. So in this VMK, all you need to do is just sit back and relax and take a look to see exactly how everything's working. If you're not interested in the details of how the GUIList control is constructed, you can skip this VMK and go to the next one, where we're going to go and take this new class and start using it within our game engine. On the DVD, where you've found this VMK, you'll also find that there's a GUIList.cpp and GUIList.h file. Take both of those and just place them inside of your object lib folder. We're going to paste those in here so we can see now we have GUIList, cpp, and .h. And once we do that, we need to go into our project for our object lib and add those two new items. So select Add Existing Items, and you want to select GUIList and GUIList.h. Once you've added them, you'll see that GUIList.cpp is added into the source files and the header file is added into header files. Now you're ready to start investigating what's in here. Let's start with the header file. At the top, I'm including core, font, color, GUI button, and GUI slider. These are all different things that the GUIList box depends upon, so we need to include these items. Our list box will be comprised of four main sections. The main body, where all the list items are going to be displayed, is going to be located inside this thing here, lc_main. If we have a slider, then the slider is going to be comprised of three parts. There's going to be the arrow up, the arrow down, and then the slider bar, which you can grab and slide up and down. Then we have our class definition for our GUI list. It's inherited from GUI control, so we see here we have public GUI control. We have a constructor, a destructor. We have a function called assign columns, assign texture, and add slider. Assign columns is used to define how many columns are going to be inside of our GUI list and how wide each column is going to be. So we have this std vector, which is going to contain integers, that's going to tell us in pixels how wide each column is going to be. If we have 3 items in this list, that means we're going to have 3 columns. The next guy over, we need to specify which font do we want to use with each of these specific columns. Now, the way that I wrote this code is, if you want to use the same font for all the columns, you will only have to specify one font. However, if you specify more than one font here, then each font will be represented by the different column here. So if we have 2 columns, we can specify 2 fonts, and then each column will have its own font. The other thing that I've done here is, if for instance you had 3 columns, but you only wanted to use 2 fonts, you only need to pass in 2 fonts here, but what will happen will be the first column will be the first font, and the second and third column will be the second font. So it automatically checks to see how many fonts you've specified, how many columns you've specified, and appropriately allocate the fonts to the columns. The last item here is the font color. Because you can specify that each column has a different color, you can go in here and specify the colors that you want to use for each column. Assign textures is very similar to what you've seen before for the GUI button, where we're going to specify the bottom left and the top right hand coordinates for a texture, and then we're also going to pass in which control item we're trying to texture. So here we might be specifying where this is the texture for the arrow, or this is the texture for the slider, and so on. If we have a slider, then the way that the slider is going to work is the GUIList is not responsible for creating the slider. Instead, you're responsible for creating the button that's going to point up, the button that's going to point down, as well as the slider individually. Once you've created them, you pass them into this function call here, add slider, and then they get attached to GUIList. and I'll show you in the next VMK how this all gets linked in together. Alright, next thing here we have add item. We call this function anytime we want to add a row of data into our list. And because we can have more than one column, we need this std vector to specify what is going to be inside each column. So this is going to be a full row of data, and each column is going to be stored inside of this vector. Also, each row can contain a specific item that this list contains. And I'll talk about more when we go into the CPP file on this. I'm just going to leave this as it is. After you populate your list, you also have the option to clear it out so that you have a blank GUI list. And if you want to do that, you just call clear all. We have some simple functions here, set selected and get selected. This allows you to set which item in the list is currently activated, so it's going to be highlighted. And you also have this function get selected to return to you the ID number of the item that is currently selected. Because you have this option here to save items for every row, you can also retrieve that item from the row if you pass in a pointer here to that item. And I'll talk about this later as well. Because we've added the ability to dynamically manipulate the location of all GUI items while the game is running, I needed to implement this move GUI item function. This is basically responsible for moving the entire GUI list, if you select that, or moving each of the individual items like the slider or the buttons that scroll up or down. So we'll need to use this, and in conjunction with that we need to use this function here, getGUICoordinate, to return to us the x and y coordinate of the currently selected item that we're moving. This is slightly different than how we did all the other controls, because this GUI list is quite a bit more complex than the other sort of more general controls that we created. Finally, we have our check hotspots, stop pressing, and render functions. And again, you need all three of these whenever you're inheriting from our GUI control class. Down here inside of the member variables, we have a number of items. First thing is a static pointer to an std vector of font pointers. This is very similar to what we've done inside of the GUI text. Because our GUI list is going to have fonts that are displayed within it, we need to have access to the container that stores all the fonts that we've loaded into memory. And this works exactly the same way that we've done the the GUI text control earlier. Down here we have a member variable that contains the texture size of the texture we're using to assign all the textures to this GUI list. We have our texture reference that we're going to be using, and we also have our 4 texture coordinates for the bottom left and our top right hand corners for each of the individual components of this GUI list. If we are using a scroll bar, this flag here is going to get tripped, so by default it's going to be false, but if we start populating data inside of this list and it's going to be larger than what it contained, then we're going to trigger this m_b scroll flag so that it goes high, and then we'll know that anytime we want to render our object, we need to also render the scroll bar. This member variable here determines for us how far we're able to scroll up and down, and I'll talk about that when we go and calculate it. And then we also have 2 colors here. We have a background color and the color that is selected. The background color, if we go into Paint Pro here, is the color that shows up behind the text. So in this case here, I selected it to be black. The other color, the color selected, is the color of the bar here that shows up over top of the text that has been currently selected. Then we have our std vectors, which contain all of our data that's inside of this container. We'll have the column widths, we'll have the fonts, and we have the font colors that we want to use. If we're going to be using a scroll bar, then we're going to have pointers to our buttons that are pointing up and down, as well as a GUI slider that we have right here. Then we have a couple more integers here which tell us which item in our list is currently at the very top, as well as which item is currently at the very bottom, as well as we need to know how many items we can fit, or how many rows can we see inside of our GUI list whenever we start rendering things to the screen. We have a value here that tells us which of the items is currently selected, And if the user chose to save specific data with each row inside of this GUI list, then a pointer to that data will be saved here inside of this variable. The actual container that is going to be storing all of the text that is going to be showing up inside of our GUI list is going to be stored in here inside m_VList. This is a two-dimensional array. You can see it's an std vector of an std vector, and each item inside of this two-dimensional array is going to be an std string. So this is the text that's going to display inside of our GUI list. And then we need also a container to contain all of the items that the user may have chosen to save with each row. So we're going to save those inside of this std vector. Finally, we have this variable here which tells us how tall is each row of data. And we need to know this so that when we're scrolling, we know how far to scroll, as well as we need to know that so that when we draw this rectangle, we know how high to represent this rectangle on the screen. Okay, let's jump right into the CPP file to take a look at the implementation for this entire class. We'll start off with the constructor. Actually, I'm going to close this off here so that we have a little bit more screen space to see all the code. If you want to get those items back, you can just go underneath View, and then you can select Resource View, you can select Class View, and you can select Solution Explorer. The other option is if you just hit this little Auto Hide button, it's going to hide it to the side of the screen, and if you need it back, you can just hit it again. So those are two options to get rid of those menus on the side. Let's start off with the constructor here. We're passing in the ID number, the position, the size, the list offset, the list size, the color of the background, the color of the selected item, texture ID, and UI max size. Finally, after we get all these parameters, we then go and say that our GUI control is going to be a GUI_list. So before I forget, what I'm going to do is just take this guy here, and we'll need to go inside of, I don't remember which file, so let's just pull up another GUI control and take a look at its constructor. We can go under the definition here, or declaration, and inside of, where are we, GUI control.h. So we'll need to add in our GUI list here. If you don't have this GUI list already implemented, go in and add it now. Let's close that off, and we can close off GUI radio as well. Okay, so what are all these parameters? Well, GUI_ID, we already know what that is. That's a parameter that's going to specify who we are. So we're going to save that inside of our member variable. Our position is going to tell us where on the screen we want to render our GUI control. So we save that inside of our member variable. The size here is going to specify how large is our GUI list, so that when we render, we know how large to make our polygon to render everything to the screen. We need to make sure that the size is not negative, so in here we do a couple checks for the X as well as the Y parameters to make sure that they're not negative. The next parameter, v2listOffset, is the offset of the location where all the items are going to be listed with respect to the location of where the position of this GUI control is. Let's go into PaintShop Pro to take a look at what this means. When our GUI list renders to the screen, we may see something like this. Well, the position of this GUI control is going to be located down here somewhere. It doesn't necessarily have to be located right here. It could be offset. That's perfectly fine. The parameter which I was just describing, v2listOffset, is the offset for the location that's going to be right over here. We need to specify this coordinate so that we know how far we need to move relative to the position over here. So I'll just write in here, this is the position, and this vector which I drew here in blue, that's going to be our v2listOffset. So I'm just going to write in here list offset is this vector here. Now, one thing to note is when I'm pointing here, I'm actually referring to the very last pixel along this row here. That's the very last location that we want to render text on the screen when we're listing all of these items. This is a very important coordinate because it's going to be used heavily to decide how large this section here is that we're going to be rendering text to the screen in, as well as we're going to be using this reference point to determine what is the size of this region here. Alright, let's go back into our code. So we've covered position, size. Size, again, let me just go back here, is going to be the overall size from this position all the way up to wherever you want to stop. So it's going to be somewhere over here. List size is going to tell us how large the area from this location all the way up to here is. So we need to specify an X and Y coordinate for the size of this region here. And that region there is going to be where we're going to be rendering all of our objects that we're going to be listing. Next guy over, we have the background color, which I already told you is the color that is black in this demonstration. And the color selected is the sort of brownish color that you see here. And the texture ID is going to be which texture are we going to be using to pull all the data from when we're rendering to the screen. And UI max size is that special parameter that you need to know so that you can scale all the texture coordinates accordingly when you're rendering things to the screen. We're going to save these two values inside member variables down below here inside of the constructor so that when we do render we can just use them. We don't have to pass them in like we did for all the other controls. Alright, so here we go. We have a bunch of checking to make sure that all of our sizes are correct values, no negatives. Then we default to have no scroll bar. Our scroll distance is going to be set to 0 because we have no scroll bar, and we're assigning all of our colors here to our member variables. We also are saving our texture ID value to our member variable, and our size, you'll remember we always subtracted 1 from it. So we're going to do the same thing here and then save it inside of m_f size. By default, we're going to set up all of our texture coordinates to go from 0 to 1, 1. So we're going to iterate through all 4 of our texture coordinates here for our bottom left and our top right hand and just set those values out. And because we have no items currently in the list, our top list item and our bottom list item are going to be set to 0. We're going to save the selected index to be 0 because there's nothing in there, and our currently selected item pointer is going to be null as well. The row height is going to be 0, and we have no arrow up, arrow down, or slider, so we're going to set these pointers up to be null. Alright, so that's just initializing our member variables. Our destructor, we need to clean things up, so if we pass in parameters here for these pointers, we need to clean them up because the user will not be responsible for doing that. So we're just going to call safe delete, and we're going to pass in the pointers here. Now notice one thing, the user may be specifying to have pointers saved for every single row of data. If the user does that, this user is still responsible for cleaning up that memory themselves. We don't do it for them. And this is a very important concept because later on you'll see that if you're clearing the entire list and repopulating it, you may not want to be deleting the user's data. So because of that, I chose not to delete the pointers that the user is saving per row here. Instead, they're responsible for erasing that data wherever they're storing it. Assigning columns. This is usually the first thing you'll do after you create your constructor because you want to indicate how many columns there are and in pixel width how large each column will be. You can have one column for your entire table or you can have more if you like. Each column of data can have its own color, so you can specify that, as well as you can specify which font you want to use for each column. Now you could mix and match fonts that are different sizes. That's perfectly fine. However, be aware that the largest sized font is going to be used to determine how large to render each row. So if you have large differential between your font sizes from column to column, your table may look a little bit funny. So we have assign columns. You're passing in an std vector for the column lists. You're passing in an std vector for the fonts and an std vector for all the colors. We check to make sure that the column width is not less than 1, that the font size is not less than 1, and that the color is not less than 1. You need to specify at least one item in each of these vectors or else the data is invalid. So if it is invalid, we're just going to return false. Then we go in here and create an iterator that's going to iterate through all the different fonts. And we're going to check to make sure that each of these fonts specified is actually valid. And while we're doing that, we're going to extract which font is the tallest out of all of them. In here, we're creating a for loop that we're going to be going through this container here. We're going to check to make sure that the column width is not less than 1. It doesn't make sense to pass in a structure that has no column width. So if that's the case, we're going to return false. Then we go in, and if we have a correct valid value for this specific column width that we're passing in here, we're going to go and save it inside of our own member variable. So we're just taking whatever value is saved inside column width and passing it into our member variable here. We then check to see if the font size, the container that got passed in here with all the different fonts, is larger than our current index here. If this is the case, then that means there are fewer fonts to use than there are columns that are specified here. So if that's the case, for this specific column, we're going to use the font that we've chosen to use in the previous column. So here you can see that we're taking the value of the font in the previous column and saving it into our structure here. So we're just adding the same font over into this container. If that's not the case, then we know we have a different font for this specific column, and we're just going to save whatever that font is inside of our container. Next, we need to figure out what is the maximum height of each font so that we can decide how large to make each of the selected items. So in here, we're going to go use our static pointer. We're going to start at the beginning, and we're going to figure out which one we're currently working with. We need to subtract 1 here because the values that are getting passed inside of this container are 1 base, whereas the values inside of this structure here is 0 base. So we need to subtract 1 here. We can get the text height by calling getTextSize on our currently selected font pointer. The text that I've used to figure out how tall it is the capital letter A and the small letter Y. I've done this because the capital letter A starts off at the sort of bottom section and it goes pretty tall. And the Y dangles down below the baseline here. So in essence, if this text here is rendered to the screen, that's about as tall as any character that you should see on the screen. So I'm taking the Y coordinate of the size of the text here and saving it inside of this temporary variable. If the row height is less than the current height of this text, then I'm going to make the row height equal to the height of that text. So this is just making sure that I'm always saving the tallest row of data inside of this member variable. The last thing inside of this for loop is I need to assign colors to each column inside of our GUI list. And again, I do the same thing that I did here with the fonts. If a unique color has been specified, I save it. However, if I've run out of colors inside of this container, then I'm just going to use the color that was specified in the previous column. And that's it for the for loop. So after doing all of this, our member variables here for m_vFontColors as well as m_vFonts and m_vColumnWidths are now fully populated with the correct column widths, the correct fonts to use, and the correct colors for every single column. Next thing I've done here is I've specified that I want to use 6 pixel buffer between rows. What that means is if we go back into here and I zoom in, you can see that there's 6 pixels between this row of data and this row of data here. If there were dangling letters, you'd actually be able to count how many pixels there are. But I don't have any dangling letters, so you can't see the difference here. This difference here is actually going to look more than 6. But I am using 6. And the way I've done this is when I've rendered this, I actually specify 3 to be above and 3 to be below. So that's the way that I've chosen it so that when I render this box, it renders centered about our text rather than offset from it. Now if you want to change this value here, if you want to use something other than 6, you'll need to change this value here, but you'll also need to change some code down below where you'll notice that I'm using 3 pixels to offset things. So you could make another variable and then use that to make the change a little easier, but I just hard-coded the 6 and the 3 down below. But I'll point it out to you when we get to that code. The last thing I do here is I need to calculate how many rows will fit inside of our GUI list. And you can see here that with any specific list that I have, if I'm rendering more rows here than can be specified inside of this rectangle, I need to know how many that is, because that's going to tell me when I'm rendering items how many to render on the screen. I don't want to be rendering all of them and then having to clip them out, because that's just a waste of rendering time. Instead, I'm going to be a little bit smart about it and figure out how many can I fit on the screen and only render those ones. So to figure that out, take the hot size in the Y direction and I divide it by the row height. This is going to give me how many I can squeeze inside of this region here. Last thing I do is I need to assign the index number of the last item inside of the list. And I can do that just by taking this value here, which we just calculated, and subtract 1 from it. Because this value is 0-based, we're going to go from 0 to 5, for instance, if there's 6 items inside of our list. And then we return true for the assigned columns. So that's what assign columns does. Let's move along to assign textures. Assign textures will calculate the texture coordinates for all of the items that we want to render to the screen. Before we assign any textures, I do a little sanity check here to make sure that the size here is not less than or equal to 0, as well as the texture ID value is not less than 1. This value here is 1-based, so if you are getting 0 here, that means that your texture wasn't actually loaded before you've gotten to this point. And normally this assignment, where was it here? Inside of the constructor. We've passed in our maximum size and our texture ID value inside of the constructor. We saved it down here somewhere, right here, but we never check to make sure it's valid because our constructor cannot return a value. So anytime before we assign a texture down here, we make sure that those values are valid, and then if they are, we continue on through. The other sanity check I do is to make sure that the parameter that we're trying to save these texture coordinates to is actually valid. You'll remember inside of here we made an enumeration that had arrow up, arrow down, slider bar, and main. Main is the last one inside of this list, which is 3 in my case. So in here I check to make sure that whatever's passed in here is not greater than the last one inside of this enumeration. If it is, then we return false. Once we've gone through all those checks, there's a few other checks to make sure that our coordinates for the bottom left and the top right are not inverted. So we check to make sure that the x's are correct as well as the y's. And then if all that passes, then we can go and calculate the texture coordinates for the specific list control that we're going to be saving in here. This is the same math that we've done for all the other controls, so I'm not going to even discuss it. And then we're going to return true. If you want to be using a GUI slider, you'll need to call add slider and pass in a pointer to the up button, the down button, as well as the slider itself. You can do that with this add slider function. We check to make sure that all these values are not equal to null, and if they are, we're going to return false because we can't handle this correctly. We take those 3 values that get passed in here, we save them inside of our member variables. We then go in and make sure that the data is already assigned to our text box, because the next items that we're going to be doing down below are going to depend upon that. Our slider is going to need to be scaled accordingly so that we can display things inside of our GUI list when we're scrolling. So down here, we need to first check to make sure what is the size of our list. This is our 2-dimensional array that's going to contain all of the data inside of our list, and we're going to just get back to us how many rows of data there are inside of this list. Once we know how many rows there are, we can multiply that by the row height, and this gives us how large of a region we have for our specific GUI list. In other words, this is how large this section here is that is going to contain all the rows of data that we're going to be rendering to the screen. The distance that we're allowed to scroll is going to be this distance minus the actual height that is visible inside of this GUI control. So in other words, as I've shown here, I think I had 23 23 rows of data. So what I do is I take 23 rows, multiply it by this value here, and I'm going to get some number, let's say it's 100. Now, I'm going to subtract from it the size in the y direction of this region here. And let's say that that is, I don't know, let's make my math a little easy here, let's say it's 50. So the difference in that is going to be 50. That tells me that the scroll bar here has a range of 50 units that it's allowed to scroll, because 50 will be displayed on the screen, but the other 50 are going to be always off screen. So knowing that, I save that value inside of this member variable scroll distance. If that value is greater than 0, then we will need a scroll bar, because there is more items that can be displayed in one complete region inside of that GUI list. If that value is negative or 0, we don't need a scroll bar because everything can fit. So we're going to set m_bscroll to be false, and our scroll distance we're going to reset to be 0. And that's about it for the add slider function. So remember, when using add slider, you have to call this after you've already assigned items inside of the GUI list. Moving on to the next function, we have add item. This is used to add text to each column specified inside of this std vector. If you wish to also store a custom variable for each item, we're going to store it inside of this pointer here. This function can only be called after assigned columns is already called, because we do a couple checks in here to make sure that the data that gets passed in here is representative of how many columns we're expecting. So first thing we do is we check to see that we actually have some columns already specified. If not, we're going to return false. We check to make sure that all the data that's going to be stored inside of this specific row has the appropriate number of columns that matches the number of columns that we've specified earlier. If this doesn't match, we're going to return false. Then what we do is we just take whatever data is stored inside of this container here and we push it into our two-dimensional array. This value here that gets passed in is by default null, so if the user doesn't specify, we're just going to push null on here. Otherwise, we're going to push whatever the user specified. And then we return true, saying that we succeeded in adding this row of data. Next function is clear all. So after we've added all the items, maybe we want to clear it. And if we do, we just call clear all, which will clear the two-dimensional array, and we want to go and clear the std vector, which contains all those custom items that the user may have specified here as well. Next function is set selected. This function is used to specify the index number or the row that we want to highlight. By default, it's always going to be the first row, which is index 0. But you can specify any index value that's valid, which is going to range between 0 and the number of list items over here. So if it's outside of that range, we're going to return false. Otherwise, we're going to save the index number as the selected index, and we're going to retrieve the custom pointer to the data from the container here that stores all the custom items inside of this member variable here. I just do this because later on, when we want to retrieve the data, which is actually over here, we don't need to do a lookup. We already have it saved inside of these variables here. So get selected, we return the index number of the selected item, as well as we can also return the p item value if it has been set. So the user will call get selected, and they can leave this blank because by default it's going to be null, but if it's not null, then we're going to save or return back to them the pointer that is currently for that selected item. And we return the selected index here straight out of this function. Move GUI items. This is a little bit more complex than what we've done before because now we have 4 different components inside of our GUI list. We need to decide which of these controls are currently underneath the mouse, and once we know that, we can then go and update the appropriate GUI control. So let me actually go and demonstrate this before I talk about the code. So here's a working version of our list box where I can scroll and select items. And if I bring up the console window and I type in GUI, we enable the GUI move ability. Now you'll notice that I can highlight over top of the main region here, and at the very top here you'll notice it says GUI 55. If I highlight over the scroll bar, it's 58. If I highlight over top of the arrow up, it's 56, and arrow down, it's 57. So I have the ability to move each of these individually. I can click on this part here and move it across. You'll notice that the scroll bar is missing now. Or I can go and grab the scroll bar and slide it across. Same thing with the button up or down. I can move these around as much as I like. So I just put these back. This is the way that you can go and construct everything so that everything lines up properly. And once you've got everything lined up, you can just go back, read off the values that are showing up in here so that you know where to position everything. Or if you've written an automatic script that saves these values out, you can automate the whole process and just use your GUI movability to lay everything out, and then you're basically done. So because we have the ability to move each of these components individually, we need that extra functionality over here inside of a move GUI item. We're passing in the current location of the mouse as well as the distance that we want to move the specific item that the mouse is over top of. So first thing we do is we check to see if the mouse is located over top of our main list box. If this is true, we're going to take the change value in the X and the Y and update the current position of ourselves, which is the main part of the list box. If this returns false, we're not over top of the main section, so we check to see if we have a scroll bar. If we don't have a scroll bar, we don't do anything. But if we do have a scroll bar, then we need to check each of the individual components. We check to see if the slider section is currently being highlighted by the mouse. If that's the case, then that's the part that we want to move. So we use the set X and the set Y position for the slider, and we update it based on whatever we get for the current value of the slider, and we update it by the change value. We do the same thing with the arrow up as well as arrow down. We change the position of each of these components individually based on the change location here. Anytime we're moving items, we want to know the coordinates, the XY coordinates of that specific item, and we can get that just by calling this function here, get GUI coordinate. Again, we'll need to know where the mouse is, and we're going to return the X and the Y coordinate here inside of these parameters that get passed in, and the return value is the GUI ID value of the item that we're moving. So by default it's going to be none because we're going to assume we're not moving anything, and then we're going to check the hotspot. If it's over top of the main section, then we're going to be returning the ID number to ourselves. If that's not the case, then we're going to check the scroll bar. If it's visible, then we're going to check to see if we're over top of it. If we are, we're going to get the position of the slider and return the ID number of the slider into this parameter here. If it's the arrow up, then we do the same sort of thing. We get the position of the arrow up, save it inside of this X and Y, and then the return value is here. And if it's arrow down, then we do the same thing down here. And finally, we just return the return value that we've saved either through here or it's ourselves if it's the main section that we're highlighting over top of. Okay, everything up till now has been relatively straightforward, nothing too complex, no heavy math involved. Check hotspot is the next function that we're going to be implementing, and this is where some math starts coming into play. We're passing in the location of the mouse as well as whether we've pressed something or not. We check to see if we're over top of our hotspot region, and if we are, we're going to change our MB over value to be true. Our return value here is going to be saved to our member variable, which is containing the ID number of our control. If this is false, then we know we're not over top of it, so we turn this guy to false. Now, if we are over and we are pressing, then we need to highlight whichever item is being clicked on. Well, we need to figure out which of the items in our list is that item that the user is trying to click on. And the way we do that is we need to know the position of our control as well as the location of the hotspot offset. So this is going to basically start over here. We're going to add to it the location of the hotspot, so we're right here right now. Then we're going to add to it the hot size in the Y direction. So now we've moved our index value or a reference all the way up to the very top here. And then what we're going to do is add the resolution offset as well, because you'll remember if we're changing the resolutions, we are going to center things on the screen. So there may also be another Y factor here. So this is our base location, and it's going to be located at the very top row here, right above where the text is going to start getting rendered to the screen. Now, we check to see if there's going to be a scroll bar or not. If there is no scroll bar, then things are a little bit easier because we don't have this extra offset here. So let's just talk about what's going on down here. I go through this entire two-dimensional array, each row at a time, and I'm checking to see if the current Y location of the mouse is greater than the Y value here minus the row height times this value here. So in other words, what I've done is, let me draw it over here. I know that the top right-hand corner here is going to be located here. And each item inside of our list is going to be something like this. So I have the coordinate of the mouse, maybe it's right here. So I first check to see, is my mouse located above this point here? So I've taken this coordinate and subtracted from it the row height. So I'm checking, is the mouse located above this region here? If that's no, then I go to the next section here. So I check, is the mouse above this guy? No. I go to the next guy. Is the mouse above this guy? Yes, it is. So I know this is the selected row that we want to highlight. Things get a little complex when we have a scroll bar, because when we're scrolling, the third item down may not be the third row. It may be, as you can see here, 1, 2, 3, it might be row 6. So because of that, we need to offset by however far this slider has slid. And that gets done here. So we take that reference value and we add to it the scrolling distance times 1 minus the slider value. The slider, the way it works is the very bottom location here is going to be slider value 0, and the very top is going to be slider value 1. So when the slider is located at the very top, its value is stored internally as 1. When it's slid to the very bottom, it's going to be 0. And we've already calculated that scroll distance, so we can take that scroll distance and scale it by this value here between 0 and 1. So if this value here is, I don't know, 0.75, then I take 0.75, multiply it by the slider distance value here, but I also need to invert the slider value by 1, because as I'm doing this check, I actually want to have 0 at the top and 1 at the bottom, because I'm working from the top all the way down. So because of this extra inversion, we have this extra 1 minus here, which gives us the overall result that we're then using as a reference. If this is the case here, if we do find that the mouse of the Y coordinate is greater than whatever we're checking here, then that current item is the one that we want to select. So we set selected to be that index. If the scroll bar exists, then we also need to do a couple checks here to make sure that the user isn't pressing on a slider or pressing on a button. Because it could be that the user didn't select one of these items. Instead, they're trying to select the scroll bar or the buttons. So if we do have a scroll bar, we check to see, well, are we over top of the slider? And if this returns true, we check to make sure that the return value that was up here, set to us, is no longer null. If it's none, then we know that we aren't clicking on a specific item, so we are allowed to click on the slider. And then we override the temp ID value with the return value here. We do the same thing with the buttons here for the button up and the button down. We check to see if we're over top of the hotspot. If the button is pressed, then we're going to default it to be not pressed because we don't want to continually press it. And then we set the value of our slider. By clicking on a button, we automatically update the slider. So all of that code is done in here. The distance that the slider is going to move when you press on the button is going to be 1 row height. And that's calculated over here. So let me demonstrate what this does over in PaintShop Pro. Let's say we had 5 items. 1, 2, 3, 4, 5. We know that this guy here is going to be 1 on the slider, and we know that this guy here is going to be 0 on the slider, assuming that this list here is actually scrollable. Well, according to this, we have a location here, and a location here. So if we take a look here, we have 1, 2, 3, 4 divisions. So in other words, the number of items we have minus 1 is the total number of divisions that we have between 0 and 1. So anytime we click on one of them, we're going to move by 1 divided by the number of divisions minus 1. So when we click on any of the arrow buttons, we're going to move by 1 divided by the number of divisions minus 1. So that's going to be this distance here that we're trying to move in. And that's what we see here. We can see that if we're pressing up, we're taking the current value of the slider and adding to it 1 divided by the maximum minus 1. And if we're pressing down, we're taking the current value and subtracting 1 divided by the maximum minus 1. So, and then finally, we just need to return the ID number here. For stop pressing, because we do have a scroll bar which does need to do some things if we stop pressing it, then if we have a scroll bar here, we need to call stop pressing for that slider. And finally, we have a render function. Again, there's going to be a little bit of math in here involved because if we're sliding things around, we need to update the correct coordinates to decide what should be rendered on the screen. We don't render anything to the screen if we don't have a texture, so if this if statement here fails, we don't do anything, we just return straight out of the render call. However, if we do have a texture ID number, we call GL matrix mode for the model view. We initialize it to be the identity matrix, and then we specify we're going to be rendering quads. We need to first render the very background of our list box. So the background color is saved as a member variable. We specify red, green, and blue. We specify that as the GL color 3F that we're going to be using, and then we render a quad using the GL vertex 2F for the 4 coordinates of the quad. And here are the coordinates that we're going to be using. Next thing that we want to render is we want to render the selected item here. So we create this V2 reference, which is a reference ID number to figure out where to position this highlighted rectangle. We need to know the position, we need to know the offset, as well as we need to know the hotspot size, and then we subtract from it the current selected item times the row height. So in other words, we'll go back here. What's happening is we start here, we go to the very top, and then we figure out, okay, we need to know how many rows are selected, and then we multiply that by the size of each row. So we're going to move down from that location. So that gives us our reference. However, if we have a scroll bar, we need to update that reference based on how far that scroll bar has moved. So again, we take that scroll distance and we need to take the slider position, subtract 1 from it, or 1 minus the slider position, and offset that in the Y direction only for that reference. Then we check to see if the reference is in view or not. The way that the whole rendering function works is a little bit clever. And I say a little bit because I've avoided using stencils to render this item to the screen. The one trick here, though, is you need to make sure that the rows of data that you have here are no larger than the section here above as well as the section here below. The reason why I say that is because when I render items to the screen, I'm actually rendering this item plus the one above it. And the one here, I'm rendering this item and the one below it. But everything else I'm not rendering. So I'm rendering the text, which you haven't seen yet, but that's going to be what's going to be rendered to the screen. Same thing with the highlighter region. If it's too far above, we don't want to render it because it may end up getting rendered over here and the user will see it, but it's not attached to the GUIList. So to avoid that, we do a check to make sure that the location of the selected region is not too far above the location 1 row above the currently top row, which would be somewhere here, or 1 below the currently bottom row, which is somewhere down here. So that's what this check does. If it's out of view, we don't render anything. We just skip over top of the rendering code. But if it is in view, we call GL color 3F. We select the color we want to use, and then we render our quad for our rectangle that we want to render to the screen. Finally, we want to render the text, which is the next thing that we see here. You notice that the rendering order does matter because everything is kind of layered. If you rendered the background last, then you wouldn't see any of the items below it because it would cover everything up. So we need to render the background first, the selected region second, the text is third, and the last item that we render is actually the border here, which is going to cover up all the text that we're going to be rendering now. So to render the text, we go through our loop of all of our two-dimensional array. We create this variable here, v2 text position, which is going to refer to this reference that we calculated up above, but we're going to offset it based on whichever row we're currently working with. If we have a scroll bar, we need to offset that text position as well based on the slider position. And then we check to make sure that the text is in view. If it's not, we're going to just continue, which means go to the next row of text. If it's out of view below, we don't need to go and check the remainder of the two-dimensional array because we know everything else is going to be off the screen because we've already worked our way down past the last row that's visible. So we're just going to break out. Otherwise, we're going to go into here. And in here we have another for loop that's going to go through every single column of data. And every single column may have a different font, so we need to extract the font that we're using for this specific column, get the text that's going to be saved inside of that column for this specific row, and then we call the print text OpenGL for that specific text that we want to render to the screen. So we specify here's the x coordinate plus some offset, here's the y coordinate of the text, and notice that here's the location of that 3 that I was talking about because we're using a spacing of 6 between our items. As a matter of fact, if we scroll up here, we'll see that there's a 3 popping up here for when we render the selected item as well. So those are all the 3s you'll need to change if you want to change the spacing between text. Then we specify what is the color of the specific text that we want to display to the screen, and then we pass in the actual text that we want to display. The column offset then gets updated by the column width that we specified here inside of our member variable, so that when we render the next column, it's located in the correct X position here based on the offset that we've specified. After we do that, then all that we have to render is the main section and then slider bars if they're visible. So again, we're going to set the GL matrix mode to be model view and set it to be load identity. You need to do this anytime after you call the print text OpenGL because this guy here is actually inside of a display list, and after working with display list, you're not guaranteed that you're going to have the same model view matrix that you expect. So you need to specify this, you need to specify identity, and then once you do that, you want to enable your texture, select the texture you want to bind to, which is the member variable we have. Say we want to render some quads. The color of our quad is going to be white, and then we go and render our texture coordinates and our vertex coordinates for that specific quad. Finally, if we have a scroll bar, we're going to want to render the arrow up, the arrow down, as well as the slider itself. Then we call GL end and then GL disable as well. So there we have it. That's all the code we need to get our GUIList up and running and rendering to the screen. Actually, as a matter of fact, now that I look at this, we should move this GL end to be located up here because these render calls are going to have their own GL calls. Here we have GL begin and GL end. So you don't want to nest your GL begins and GL ends. Okay, so just do that, make that one little change. Well, actually, I'll make the change for you, and we'll have that updated version of the code on the DVD so that you won't have to retype any of this stuff at all. So come back for the next VMK where we'll take this GUIList class and start using it to implement our new game state, which is going to be using this list.